I'm Nicolas Gassoin, professor and attaché for science at the French Embassy. I'm very pleased to welcome you today. This is the 20th conference we have since 2016. This conference will be in English. So I'm very pleased to welcome today Professor Antoine Doucet from University La Rochelle in France. Antoine is a full professor at the University of La Rochelle since 2014. He's also the director of the department in telecommunication, informatic and communication technologies in Hanoi, in Vietnam. His research are based on looking for information and signal processing of languages and post-processing of massive data. This conference is organized together with FEO, École Française d'Extrême-Orient, and I would like to particularly thank its representative, Véronique de Groot. She's a professor in archaeology, working in Indonesia since a long time, and we are organizing this cycle of conference since 2 years together with FEO, and I'm very happy to inform you that next year we will do again this conference cycle. We will have 12 more conferences next year. I would like also to thank Comunitas Historia Indonesia for participating to this conference. And I would like to have a special thank to UIN, Universitas Islam Negeri Jakarta. We are waiting for some students, quite a lot of students. It seems that 100 students are on the way, and the catering is offered today by UIN Jakarta. So I would like to thank them for this last conference of 2017. So before I introduce the speech to Antoine, you may have seen this book. So this is it is free. You can just have it outside this room. This is a compilation of all projects which have been presented to you since 2 years. So this is a French contribution to the understanding of Indonesian heritage, history, culture. So all the presentations were made by French researchers working in Indonesia. This is a contribution of France in terms of cooperation for science. And so now I will give the floor to Antoine. I've been quite long. So please let me introduce Antoine Doucet, professor of University La Rochelle, on the topics multilingual news surveillance, how to detect events in real time. So please applause, and I give the floor to Antoine.
Thank you, Nicolas, and thank you, I want to thank the Institut Français and the FAO for inviting me. I'm very pleased to be here. And I will, well, you already know the title. I will tell you about multilingual news surveillance. So basically how we can use computers to understand text in multiple languages. I will show you there's very many challenges and very important impact in the processing of big data and all of these masses of data that are produced every day by humans, by computers, and that need to be understood and that can be used for lots of useful applications. So the main problem we have when we want to understand data, for instance, text, most commonly we want to compare documents. So if you think about what everybody does every day, maybe some people even now in the room, when you use Google or a search engine and you type a few keywords, you're comparing your keywords, your list of keywords, to all the documents on the internet. So you have billions of documents, you compare your keywords to one document, one document, one document, one document, a billion times, or billions of times. And then you get scores, and the search engine is trying to tell you what is the document that looks most like your keywords, and then assumes that you will be satisfied with that answer. Of course, it's a lot more. There's a lot more. There are many more things behind it, as you might know, like PageRank and history of user satisfaction. There's user feedback. If people were satisfied with the answer, then the answer is more likely to be first in the next queries. But basically, the idea is this: you have your keywords, and they are compared to all the documents on the internet or in the index of the search engine. But for some reason, comparing billions of documents to one few words query is done in less than a second, less than 1/10 of a second. Actually, most of the time is for data transfer. It's actually almost done instantly. So how is that possible? It's possible because documents are modeled. Text is very hard to understand for computers, especially because computers only understand numbers, zeros and ones, the binary language. And of course, human language is much more sophisticated than that. For us, our language is clear. Other languages are, sometimes we can understand them a bit. Sometimes we absolutely do not understand anything. And for the computer, by default, it does not understand anything. It's just zeros and ones that don't make sense unless you have a code to understand it, dictionary, some rules of grammar, and so on. But we can actually do a lot without understanding anything. I will show you how. So basically, the way that all these comparisons can be done very fast is because the text, the human language, is translated to numbers. And everything, all the documents are transformed to numbers, and your query is transformed to numbers, and numbers are compared. And briefly, that's why it's fast. It's because we do modeling. We model documents. We represent them by numbers. In the work I will present tonight, and in the work that I've done actually most of my career, we take a strong focus on bringing up or creating solutions that work for any language or any kind of document. There's a reason for that. Of course, we can use dictionaries. There's lots of online dictionaries. There's a lot of resources. You can find a lot of information in Wikipedia. But we want to design techniques that work for every language in the same way. And the reason, there's many reasons for that. One of them is that many languages are what we call low-resourced languages. If you take English, for instance, and also French, there's lots of resources. You have tools, automatic tools, computer tools to use a dictionary, to find synonyms for words, to understand the grammar of language, the part of speech, what is the subject of a sentence, what is the verb, what they mean, what is the relation between the subject and the verb. But for most of the languages, there is none of that. And you still have to be able to process these languages without these tools that don't always exist. The reason to do that is that unlike people have thought maybe 10 years ago, people thought that the internet will be in English and English will dominate everything because all the documents are in English. I mean, most of the documents were in English, so there was an assumption that all the documents that will be created will be in English, and English will just rule the internet. It turns out, now we all know it, that it's going the other way around. The share of English documents in English language is going down, and all the other languages are actually increasing, or most of the other languages, including the languages for which we don't have linguistic tools. So we need to be able to process them as well in some specific cases that I will show you. So I will focus this talk, as it was said in the introduction, I will focus on news surveillance, specifically in the case of epidemics. The task that we are facing is that we want to know, we want to look at all the news that is published online. So every news article that is published online, we want to basically know if there's a case of a disease, if there's a new case of a disease, what disease, where is the case, and what is the status of the people who get the disease. So basically, if there's, I don't know, dengue fever in France, we want to know it. It's unexpected so far, but or if there is, I don't know, any kind of new disease that comes, I don't know, tomorrow in Sumatra, we want to know it. We want to know it as soon as possible, and we want to know where, and we want to know who. And there's the reason why do we want to know that? Actually, who wants to know that? World Health Organization, European Commission for Europe. In France, we have an institute for sanitary surveillance that wants to know in real time who is sick, how many people are sick, what disease they have, is there a new epidemics coming or not. And it's very hard to know because the way to know it is to ask doctors, but the doctors are quite busy and they will report, but they will not report in real time. The best way, and the doctors, I mean, they will report when they are told to report. They will report if their government is telling them, but it does not happen worldwide. But actually, there's lots of news published every day in very many languages. And because the task that we have is to find, I didn't underline this, you want to detect, you want to find who is sick and when, and you also want to know it as soon as possible. The World Health Organization wants to be the first to know. If they get information from journalists, it means that journalists have been writing an article about it. I mean, sorry, if the World Health Organization gets information from newspapers in English, it means that English newspapers have been writing about it because English-speaking journalists know that something happened, and they heard it from somewhere else, and they wrote about it, and a lot of time has gone. So basically, the best way to get the information as soon as possible is to get the information from the local language, from the language where the case has happened first, because the first article that will be written about new disease in Thailand will be in Thai language in the Thai news. And if we only analyze English, we will get the information, well, too late, which means, I mean, at least much later, because we will have to wait for a journalist to get basically manually the information that there is something important and I have to write about it in my language. And that's, in the eyes of the health organization, is too late. So the only way to be reactive, the only way to get the information early is to handle as many languages as possible. And basically all the languages is the best option. The problem is that in the field called natural language processing, which I mentioned earlier without naming it, it's a field, it's the domain where you try to use computers to understand human languages. In natural language processing, to detect an event, to detect a case of a disease, for instance, is done by techniques that rely on linguistics, on specific parts of linguistics. You didn't need lots of tools that are briefly mentioned earlier. So basically the way that you would do newspaper surveillance online is that you would first get a document, so an article, a newspaper article. Then you would do what is called morphological analysis. So you separate all the pieces of meaning in the word. So if you have cats in English in plural, you have to separate it because you have cat and you have the S at the end. That means that it's plural. So it's actually two parts. And so basically you want to decompose everything and try to understand all the meaning that's in your sentence. You want to do stemming, so remove the different declinations of the words. You want to use stop lists, so you want to remove, for instance, words that are not very meaningful, like articles, the, or maybe but, or maybe maybe. And you want to, so basically you want to remove all the words that you assume are not very useful for your task. And you have to list them. You want to do the grammatical analysis. And all of this, obviously, all of this, if you do it for English, you have done it for English. But then if you want to do it for Bahasa Indonesia, well, you have to do it again because the tool for English will not work. And if you do it for the next language, well, you have to do all the tools again, specifically for that language. So obviously you have a problem because we have the number is going down all the time, but we have, I think, we had in the last time I checked, 6,000 languages in the world, and we don't have 6,000 tools for doing the morphological analysis of each of these languages. We don't have it for the grammatical analysis, and so on. And even when you have done that, you are quite far from the end, because you have to do some more linguistic analysis to find out, to understand the sentence. You have to find the name. Are there names of peoples? Are there disease names in the text? Are there locations in the text? And once you have people name, diseases, and locations, you already can see that we are a lot closer from our task, which is to find what disease is happening where and when. But we still have to use the text that is written. We still have to use the grammar, sorry. So basically the last step in all these techniques consists in building a very, very large database database of what is called syntactic patterns. So I will explain, I will give an example. So basically if you have a sentence, you want to list all the possible sentences that tell you that someone caught a disease in some place. You want to find all the different forms. So there's many forms. In English, you could have somebody caught hepatitis A in Madrid last week. But you could also have it in a different way. You could have, first you could have last week, somebody caught hepatitis A in Madrid. You could have it in many different orders. You could also have it in different forms, different passive or active forms. Hepatitis A was caught by a person last week, and so on. And you have to write lots of rules, grammatical rules for all the possible cases that will trigger an event that you can detect. And of course, all these rules, you also have to write them. You write them for one language, and you write them again for another language, and again for another language. And of course, that's not very realistic because you will do it for the languages that have the most share of newspaper documents, but you will not do it for every single language. So you will do it. I mean, all these systems, they exist for English, French, Spanish, Chinese. For Bahasa Indonesia, I know that some of the parts are missing. I mean, some of the linguistics tools exist, but not all of them. So it will not work very well. And basically, for many languages, it doesn't exist. For instance, if tomorrow you have an event in Philippines in a place where people speak Tagalog, you will have an article in Tagalog. And all the surveillance systems will miss it because they don't know how to process it. So, oops. So you need, so this is the tool you need for one language. And for every language, you have to get all the tools for the language. But we decided to try something else with some colleagues. We thought that we decided to use what you can call language universals. And language universals are things that we hope are true for every language. And what is true is that we are looking at news. What is in common with all the text is that we are looking at news. We are looking at newspaper articles, and we want to find which newspaper articles talk about diseases or epidemic events, and we want to find which epidemic event and where it's happening. And well, we know that there are rules in the journalism that are the same everywhere. And the rules in journalism, it's called pragmatics. The rules in journalism is that you have to, you have to give a title to make people read your article and also for them to know what the article is about. And you always try to get your message through. It's also a rule of communication. You want to make sure that your message, your main message is understood, so you will put it in the title or in the beginning of the document, and you will repeat it. The most important thing, you always repeat it. Same thing when you give a presentation or when you give a class to students. You give your main point, your main message in the beginning, you mention it again, and you give it again in the conclusion. And that's what journalists do. And when you want to repeat your message again and make it very clear, make it sure that it goes through, usually you use the same words. At least that was our assumption, and we verified it. So we decided that we want to see how far we can get with absolutely no understanding of the language, no resources, no grammatic analysis, only a very small set of keywords, a list of diseases, and a list of locations. And then just make this assumption that the important stuff, I mean, the main message of all the articles is repeated, and it's repeated in a very similar way. So what we exploit is the position of words and the repetitions. And we exploit them at the character level, and I will explain why later. And we can extract this is location pairs, and this is a number of cases pairs. So basically, I forgot to mention this, but when there's an epidemic event, we also want to know if if it tells about 25 people who got the disease or one, of course. So here is an example of what we do. We have a report here from the World Health Organization. I'm sorry, we have an article. It's not by the World Health Organization. It talks about the World Health Organization. So we have this small article, or actually the beginning of the article because it goes on. It's about smallpox in Uganda. So it's just the example that I will use to show you what we do. So first, we check repetitions in specific positions. So we look for repetitions, all the characters, all the strings of characters that are repeated. So all of them are now in bold. So WHO, well, the World Health Organization is repeated because it's here. Smallpox is repeated. Reports is repeated. And so on. Uganda is repeated. And we do it at the character level because, as you can see, we have investigate without the E at the end. Because here we have investigating. So, but the first part is common. And you can already see why we do that, because it's the same word in a different form. But we don't want to miss the fact that it's the same word. Of course, for this word in particular, it's not very useful, but in some cases, it will be very useful. The next thing we do, we have a list of diseases, and we have a list of locations, like I told you earlier. And we will cross this with those lists. So in red, this is names, and in blue, locations. And what happens? We have this is name, it's repeated, and we have a country name, and it's repeated. And simply we extract that we have a case of smallpox. We have this is location pair of smallpox in Uganda. And interestingly, so for English we can interpret it, but then we try it in other languages. Polish, which I don't understand at all. And we notice that we have a location, Thailand. And we find it because there's many, even though there's many ways to write it, because here it's Thailand ski, and here we have Thailand D, but the common root is Thailand, and we catch it. And then we have dengue and dengue, and we catch it. And we know from this Polish document that we have 43 victims of dengue fever in Thailand on the day of publication of the article, at least mentioned in that article, without understanding any Polish. And actually, yeah, I mean, actually, we can guess it even without understanding any Polish, because we don't understand much. At least I don't understand anything. But when I see that Thailand is highlighted, it makes sense, and this has to be dengue fever. And of course, we checked it is. And it also works in Russian, where we have here the H1N1 virus, the avian flu. And it also works in another language I don't understand, which is Arabic. And in this case, you can see that we only have the disease. I don't remember what it is. If someone speaks Arabic, maybe they can tell me. I don't remember what disease it was. We have only one mention of the place, because in many cases the location is not mentioned in the article. But we found out, we also verified this, that when the location is not mentioned, the reason, well, if you read the news in Indonesia, if you read an article, I don't know, in the Jakarta Post, and they tell about an event, but they never give the city name, the name of the city where it happened. Well, 99% of the time it happened in Jakarta, right? So every time we don't have a country, we assume that it's a country where the newspaper is published. And that of course, that works very well. So here we don't have a repetition of the place name. There's a place name here. So we assume that the event happened where the newspaper is published. So the results that we have are actually quite good. So I have to explain what is recall and precision. We made experiments in over 40 languages. Of course, making experiments, I mean, when you do experiments, you have to be able to tell if your results are good or bad. And to know if your results are good or bad, you need to have people who can confirm. You need to have experts who understand the language that can tell you, yes, your system is correct, or no, your system is wrong. And that's why we only have 40 languages, because we could find people to evaluate the results only in 40 languages, because as you understood, we can run this in any language. It doesn't matter. We don't need any information, any external information. Actually, we need one piece of external information: the list of diseases and the list of countries, or the list of locations. But this is very, very easy to get, because we have something called Wikipedia. And in Wikipedia, we have a list of infectious diseases. There's a page called List of Infectious Diseases in English. And you probably have done this before. There's always something that they call a translingual link in Wikipedia that points to the same document in another language. So when we need the list of infectious diseases in Thai or in Arabic or anything, we just go to the list of infectious diseases in English, and we go to the page in the corresponding language. So the next question, the way to measure it is to compare how fast our system can find a new event compared to the network of human epidemiologists that have a mailing list where they share all the information that they have in their country. And this is the official way that medical doctors get, I mean, not really medical doctors, I mean, medical doctors specialize in epidemiology and typically working for a World Health Organization. They have this alert system where they inform that, oh, in my country there was this event. And the question is, does our system give the information before the doctor who gives the alert to the others? So not surprisingly, so we have this column that gives the first reports. So only 15% of the time we are faster than the doctors in North America. But in North America, the language is English and Spanish, and the systems are very well trained for those languages. In Central and South America, the same. In France, Portugal, Spain, UK, in Europe, of course, English, Spanish, French. We don't do very well. We are faster only 28% of the time. On the other hand, it's not much, but if we can combine and make the detection faster 28% of the time, it's not bad. But where we are good, of course, is for the languages for which there is no system. So Czech, Greek, Finnish, Italian, and Swedish. And here we are most of the time faster than the other system. And I should have digged and get more information, but for China, India, Russia, there are lots of systems too. But for everywhere else in Asia, we are faster. So it shows that there's a real use. We can find events faster than all the existing systems, and we can help the epidemiologists to get their information faster. And actually, this was very unexpected, but because this is originally, I'm a computer scientist. I've been focusing on natural language processing for most of my work, so understanding languages. And I have, of course, a small training in linguistics. But interestingly, with this application, we received a prize for the best paper in 2015 by an association of a medical association, which is some field I've never worked on and I have no knowledge about. But it came to the attention of the medical, what was it called? The International Medical Association, that this was a very useful paper in the field of, the most useful paper in 2015 in the field of public health, which is nice. So this was mostly the work of a PhD student, former PhD student of mine, who is now an associate professor. Just to summarize, the process is fully alingual, so it's not using any language, basically, with very low resources that I mentioned, so 500 words per language. So that's on average the number of infectious disease names and the number of countries. So the resources are very small, much smaller than in the state of the art, where you remember we have to have all the syntactic patterns, all the possible ways that you can mention an epidemic event for each language. Execution time is fast. So execution time means we can process much more documents than the other systems in a limited amount of time. That's nothing special, it's just a consequence. It's very useful, but it's just a consequence of the fact that what we do is much more simple. We don't have to do a linguistic analysis, so we don't need processing time for it. It's that simple. We just look for repeated strings of characters, and that there are very, very good algorithms for that. And we have a platform. If you want, you can go there where you can check the results. You can take the URL and test it. We have the system is called DaNIEL, and you can there's a link called Test DaNIEL, and you can copy paste the document in whatever language you want, and see if the system finds an epidemic event or not. I have quite many perspectives. I will skip some of them. The main perspective, at least the most related perspective, is that what I just showed is about epidemic surveillance. It's about finding cases of epidemics, the place where they happen, and what happens, and when. In most of the systems, what I didn't mention earlier, all the systems, they have these syntactic patterns that tell you all the ways, all the possible ways that that an event can be described to notice that there's an event. They are written specifically for one language, but they're also written specifically for diseases, for epidemic events. If you have built a syntactic pattern, I mean, if your syntactic pattern is, what was my example? Someone caught hepatitis A in Madrid. Well, you cannot apply this syntactic pattern to detecting event in finance, right? So if you want to work on another field, for instance, finance, or for instance, detecting terrorist events in the news, well, you have to write new syntactic patterns for one language, and you actually have to do it again for every language. But in our case, the only thing that binds us to the field, to the domain of epidemic events, is country names and disease names. So we could quite simply, with different keywords, adapt the system to other domains. And actually, one solution that we have not implemented yet is that we could do the first part of the system that I showed you, where we look for repetitions, repeated strings in the beginning and in the second part, or later in the document, and find all the events. And later, when the user comes and says, oh, I'm interested in epidemics, or oh, I'm interested in finance, and I want to get new events in finance, or I want to get new events in new terrorist attacks live, and be informed as soon as something happens, if something happens. Well, this can be done afterwards. You could imagine that we build this huge database of everything new that might be an interesting event, and let people search it. So basically, that's I think a very interesting future work. I will skip a bit more. The next, yeah. The next applications that we are working on. Other implications of this work. That people are very interested in detecting events on social networks. For instance, Twitter. If there's an earthquake, everybody will write something in Twitter that they would not write in if there was no earthquake. Or there will be a different behavior, different topic. Some new topic will emerge immediately in the area where it happens. And everywhere else, people will not know that there was an earthquake until the specialists have started communicating about it. I'm talking about earthquake, but earthquake is maybe not the best example because there are so many tools that are noticing every shake live. But this also applies to terrorist attacks, to well, volcano events or anything. So the problem with social networks is that the systems, like the one I mentioned in the beginning, the systems of the state of the art, they are not really able to deal with social networks, because when you write in Twitter, you don't write as well as a journalist. Or most people don't. And of course, you don't have the space for it. You don't write a 1,000-word article. You write 160 characters, and I think now 300, what was it now, 320? 280 is the new, okay. So it increased recently, but I forgot how much. You still will, 280 characters is not always enough to write carefully. And of course, if we try to detect events, this is, I mean, if your home is collapsing and you want to call for help, you will not use your best grammar, right? So the systems don't work because the grammar is not good, because the vocabulary is not good. So systems where we don't use vocabulary and where we don't use grammar have a good chance to be efficient here. And this is a project that I work on with colleagues in Universitas in Indonesia, in Depok. The next big thing, the next big, at least big plan, and it will interest everyone who he's a historian and in social humanities, is that we can work on the ancient news. There's in every national library and in every country, people are digitizing people want to basically keep track. I mean, now that we are in the digital world, people want to keep track of their history. People want to preserve all the important documents of the patrimony. And newspapers have been published since the 17th century. They have lots of interesting information. Some of them were daily, some of them were weekly. There's a lot of information, and actually there's way too much information for scholars to exploit. And so far, so national libraries have spent a lot of time and a lot of money to digitize all newspapers. However, scholars are not yet able to use them for one simple reason. The quality of the documents is not very good. And when you digitize them, you don't get the text correctly. You get pictures, you take pictures of the documents, but to extract the text, you have many errors. And when the scholars are searching a database of ancient news, they don't find what is in the collection because it's not recreated correctly. So one thing that I have in mind is that maybe we don't care. Maybe we can find events even if the text is wrong, is partially wrong, even if there's noise. Because we don't need dictionary, we don't need grammar, we don't need exactly what is missing. So we could find events with text that is partly incorrect. And this is actually last week I received news that we have we will coordinate a big project funded by the European Union with 3 national libraries and 4 groups of humanities, 3 of them historians, that will precisely focus that will precisely aim at this. We will improve the quality of the text. We will use the methods that are presented to find events, to find persons, to find locations. And we will give a much better access to all the scholars who will then be able to do proper, exhaustive history research based on a very large data set that they are not able to process by hand. And that's the main other continuation. And I wanted to stop here. This is a bit abrupt. I thought I forgot to repeat my message in the end to to make sure it goes through. But on the other hand, I've been repeating it every 2 slides. So I hope it worked. And I'd be happy to hear your questions.
Thank you, Antoine. So I think we can dedicate it something like maybe 15, 20 minutes to the question. Yes.
Excusez-moi, je dois parler français parce que je voudrais savoir on comprend ou pas mon français. Oui, la question que je voudrais vous poser, c'est ouvrir le website. Bien souvent, j'ai trouvé une difficulté. Parce que si je voudrais envoyer le message ou les questions, il me donne le portal, ce qu'on appelle le portal, c'est-à-dire les codes que je dois résoudre. Je n'ai pas réussi là, de surveiller. Bien souvent, je me demande, est-ce qu'il faut être contacté ou il ne faut pas être contacté? Voilà, comment vous approuviez tout cela? Vous comprenez mon question?
Vous voulez que je réponde en français ou en anglais?
Oh oui, évidemment, en anglais. Oui.
Oui, non, mais c'est pour les autres. Je voulais savoir quelle était la règle.
Oui.
Okay. So, but En fait, je suis pas complètement sûr d'avoir compris. Vous avez eu du mal à accéder au site web, c'est ça? Le Daniel.
So the question is about how to access the online
Celui-là?
website to test.
Ah. Ouais. Oui. Ouais. Ouais.
Is it possible for your software to detect messages in private message, or is it only based on public message?
Oh, you mean for social networks or?
Yes, for example.
No. Well, basically, we have no access to private messages, so we cannot process them. Well, in theory, if you were getting the software for the tool, you could run it on your own messages, but we are university, so we don't steal people's data, and no, we don't. I'm kidding. We don't store people's data because we have no access to it, and well, there's very strong rules of protecting personal data, which we are happy to follow for our own sake.
Okay, pas? Yeah? Okay.
Merci.
Another question?
Hello, my name is Novia. I would like to ask if the disease is totally a brand new one. I mean, you have said that we can search for the keywords in foreign languages we can search for the keywords in foreign language in Wikipedia, but what if the disease is really new one and there has never been any word for it? So how could we search for the new epidemic disease? Thank you.
That's a very good question. Sorry, I was looking at the slides because somehow I had a feeling that this is addressed in one of the slides that I skipped, but it's not. It's a very, very good question because, of course, that's a true, real problem. We use Wikipedia. We have the same problem that languages with many speakers are more likely to have an up-to-date list of infectious diseases than languages with less speakers. Simply, in some cases, the name of the disease doesn't exist yet. We had an example about H1N1. First, it was H1N1, or A/H1N1, then it was H1N1, and then people started to call it avian flu. And then the name actually shifted in a very brief period of time. So we are not addressing it yet, but we have an idea on how to do it. You can do it with machine learning, if you know if that sounds familiar to you or not. So the idea, but you don't have to get the details. Basically, the idea is that you have we can learn in text. This is verified in natural language processing. In text, the words of the same what is called semantic field or with the same role. So basically disease names, they will often have the same context. So it's a bit like what I said about the syntactic patterns. If you have a disease name, especially in press, quite often around it, you will have words about being sick, or being dead, or being ill. And this will be an indicator that there's a disease name somewhere there. And the way that we could find the new disease names is that we have, with our system, we can find all the existing diseases, and we can look what's written around them. And every time we find something that looks like what's around the disease name, but we don't have a disease, but we don't find the disease name, we could have an alert that says, look at that, maybe it's a disease name. You know what I mean? Yeah.
Thank you.
So we basically build knowledge that we can use to get new knowledge. And yeah.
Thank you.
Do we have another question?
Hi, my name is Sigit. I have a couple of questions. One is that basically what I understand from your presentations, you basically define an event based on some keywords, and that without really reading into the content of the article or the message itself. I mean, how could you basically understand that? How could you basically derive an event based on the keyword without understanding the whole message of the event? And the second question is that how do you identify if the message or the keyword that is available in the, let's just say in the internet, in the media, or in the social media is not a hoax? Thank you.
To the first question, well, this is basically the whole idea. When we started working on this, we had the same question as you. Like, can we really get that something is an event without reading the whole document and understanding the whole document? Basically, a metaphoric way to describe what we do in this project is it's like when a human, you take a book or a newspaper. Well, actually, you take a newspaper. You don't want to read all the articles, or at least if it's a daily newspaper and you get it home every day, well, you don't have time to read all the articles. But you go through them. In French, we say in diagonal. I think in English it's skimming through. So you go through it, you turn the pages, you look at the title, and sometimes you go through the article and you read it like every second line, or you look at a few words and you see if something catches your curiosity, and if it does, you read it. Basically, this is what the system does. We try to find these disease location pairs to tell us that there's probably a disease in a location, and we also reinforce it by what we know about the way that journalists write. Luckily, they write quite well, and their goal is to give a message. And to give that message, they repeat what they say. They repeat the same things. They repeat the main message. And if the main message is that there's a disease somewhere, there will be many mentions that there is a disease somewhere. Maybe with different phrases, different text around it, but there will be the disease name and the location more than once. So that was our assumption. We were not quite sure that it would work, but it turned out that it works. And of course, the output of the system, what you get out of it is not a full description of what happened and where. You get an event, and then the event tells you, look at this article, it's interesting for you, if you're interested in epidemiology. And to the second question, how do we find a hoax? That's a huge, how do we find fake news? That's a huge problem right now. Well, we have no solution for that. That's an emerging problem. I think it's always been there, but it's become much bigger now. If a journalist writes something very convincingly, something false, well, we will fall for it. I mean, the system will fall for it, definitely. Yeah, the way, I don't know, in social networks, I mean, there are many. It's the way that it can be detected is based on there are many approaches, but the way it's written, sometimes there's a link, usually there's a link, and if the content of the link is not very consistent with the text in the tweet, then you know that it's quite suspicious. It's like clickbait. But in the news, we cannot do much. But on the other hand, I don't